Dragi gledalci, dobar dan. Vi gledate još jedno izdanje emisije Pola, sata, Demostata. Danas nam je u gostima profesor sa Univerziteta u Austriji sa kojim ćemo intervju voditi na engleskom jeziku. U ovom intervju pokušat ćemo da razotkrijemo šta je to čime se on bavi, kakvi su sve uticaji na životnu sredinu kada su u pitanju neki novi projekti koji se pripremaju u Srbiji i šta on sa aspekta svoje struke o tome ima da nam kaže. Professor Tost, hello and welcome.
Hello, thanks for having me.
Great. I would like to tell a little bit more to our spectators about you. So, Professor Dr. Mihael Tost, the head of the Department of Mining Engineering and Mineral Resources Economics at the University of Leobenu in Austria. He holds a PhD in mining and a master's degree in environmental engineering from Montan Universiteit Leobenu. He has industry experience because he worked for Rio Tinto over a decade ago and served as the head of the mining and metals division at the World Economic Forum in Switzerland. Also, there is an interesting fact that Professor Tost also is a passionate mountaineer who enjoys endurance sports and nature, which is very specific. Exactly. When it comes to mining as well. So let's start with the first question. Climate change demands a transition to new technologies, those that reduce or eliminate greenhouse gas emissions and decrease the reliance on fossil fuels. However, new technologies also have some risks. Is it possible to anticipate those risks?
I think we have to do that in order to avoid mistakes made in the past. So when it comes to those new technologies, when it comes to projects, for instance, we have to do mining projects. For instance, we have to do environmental, social impact assessments beforehand to look at those risks, analyze them, and also make plans to avoid those risks to materialize at the later stage when it comes to the execution of the project.
Mm-hmm. The public here in Serbia and in general in Europe is increasingly involved in the very early stages of implementing new projects and is particularly sensitive when it comes to the word mining, but also environmental effects of mining. So can new extraction and processing technologies actually guarantee the preservance of nature?
Mm-hmm. I would actually say there is going to be an impact on nature. So that is the nature of the mining process, that it has an impact. But then with new technologies, for instance, we can reduce that impact. For instance, use underground mining instead of open pit mining. You'll reduce the impact on the land. Another aspect that is of relevance is that mining is always something that is only going to be around for a number of years. Yeah, that might be 2 years, it might be 6 decades, it might be 100 years, but ultimately each mine comes to an end, and then you have the opportunity to rehabilitate that land as well again, and then use the land going forward.
So nothing is black and white, actually, in mining.
I would say yes, exactly.
But there is always a question in our public, can all these technologies be environmentally safe?
Again, they have to be environmentally safe. So going forward, I don't think we can afford anymore to make the same mistakes as in the past. So we have to plan those projects in a way, as we can see at this stage, to make them as safe, as environmentally friendly as possible.
Currently, one of the most discussed topics in Serbia is the launch of the Jadar project and how, since you have collaborated with this company, you have expertise to tell us perhaps a little bit more how this company works. And I can tell you that currently in Serbia, there are so many opinions and the public here is confused. They don't know whom to trust, whom to believe. In this context, from the perspective of your expertise and your past work, which is what interests the local public the most, how safe and tested is the technology that would be applied in Jadar project if that is to be realized?
Mm-hmm. So I guess from a starting point in terms of the data, you have to look at the data. Yeah, don't look at opinions that are out there in social media, etc. So look at the data. And for instance, one thing, and what I mentioned before, this is going to be an underground mine. It's not going to be a big hole in the ground, i.e. an open pit mine. And with that, you actually already reduce the impact on the land. In fact, in much above on the surface there, agriculture can actually continue at this stage. So the point I want to make is look at those facts, look at the data out there, rather than at the opinions that might be out there on social media.
Mm-hmm. And there is a lot of opinions circulating in media in Serbia. So especially about the effects that this kind of project can have. How will this project affect groundwater based on your expertise?
Yeah. So there is, I think, two things we need to distinguish. One is the mine is going to be, or where the mining is going to happen, that's somewhere at a depth of 400 to 700 meters. And water that is down there is not the water that you would consider as groundwater, i.e. to be used as drinking water or to be used at agriculture. So the wells are down to like 20 or 30 meters. Yeah. So that water at the surface that you are going to use is not connected to that water down at 400 to 700 meters. So that water down at 400 to 700 meters where the mining actually happens, that's going to be collected. That's then going to be used, or the majority of the process water to be used then at later stages after the mining process, where you get the ore out, when you do the beneficiation of that ore, then that water collected in the mine is going to be used. And then any water that is collected on the surface, again, is going to be used. And any water, if there was water, it's going to be recycled in the processes. And if there was water that would be on top of what is needed, it has to be cleaned. And there are plans for this water to be cleaned, reverse osmosis process, and however the technologies are called, before it is then again released back into the environment.
Can you please explain a bit about reverse osmosis?
Yeah, so that is one technology that is being used to clean water. It's actually a very advanced technology for cleaning water because it really gets metals, very fine materials out of the water. In this case, even so that you have to remineralize the water afterwards. When you put it back into the river, you have to put certain minerals back so that it's aligned with sort of the generic water or the water that flows in that river naturally.
Mm-hmm. So that it actually can be saved to be used
exactly
later. And what about the soil? We have a lot of things going on when we say, oh, there's going to be this project, and people say, okay, this is an impact for water, but this is also an impact for soil.
Yeah, again, the mine is going to be an underground mine, so 400 to 700 meters underneath the surface. So that doesn't have an impact on the soil at the surface. The processing is being done at the surface, but all of that is going to take place, as the plans are, in closed systems. And in addition to that, you actually put those closed systems again on top of concrete floors, for instance, so that if there was a leakage in those systems, in your processes, the water doesn't go down into the soil, but there is another layer of protection before this could actually even happen. Then there is this third element in a project, which is sort of the waste storage. And once again, when it comes to the waste storage as it is planned, that's not going to be directly on the ground, but again, there is some lining and protective systems on top of which that waste is going to be placed.
Leakage is also something that people are afraid of, I would say here. So from your perspective, how can leakage happen?
Mm-hmm. So in this case, I would actually say respond to how can it not happen. So again, you put that waste on top of those sort of special linen so that water cannot get into the ground. That's one thing. The other thing is the methodology that Rio Tinto is going to use for the waste disposal is called dry stacking. So you actually don't put wet materials in that waste disposal area, but you put it there in a dry state, which means that you can compact it really, really well. And compaction means that the water cannot get into that material on the one hand, so you minimize water getting in that material. And in addition to that, there's another benefit. It reduces the land requirement for your waste disposal. And on the other hand, what you can do as well then, and what is planned here as well, is you put this protective layer that you put underneath the waste material as quickly as possible on top of the waste material as well, so that water cannot get into the waste material. So it's compacted, which reduces the risk of material getting in, and you try to cover it as quickly as possible. And then that water actually runs off kind of to the outside of the material without getting into it.
When you put it like that, we can say that there is a lot of layers of protection.
Exactly. Yeah, you don't rely in the setup of those projects. You don't rely on just one layer of protection anymore, but there is 3, 4, 5 layers of protection that are being built into those plans.
Yes, it's important that we actually explained that. So when you see, as you said, things that are opinions, you do not see these kind of unexplained facts. So we as people that are not in that profession cannot know what is going to happen there.
Exactly.
Also, speaking about opinions, one of a very, very broad theory here is sulfuric acid and sulfuric acid rains that possibly the Jadar project might cause, as some people have been saying. So from your professional perspective, is this project environmentally safe?
So from that point of view, when I actually saw that question and heard about that, my first reaction was that I had to laugh about this, because if that was to happen, then something would have gone really, really, really wrong. And it's, I would actually even say, impossible for that to happen. Yeah. So the way sulfuric acid is being used in the project is once again in the processing stage. So it's not going to be used in the mining part. That was something that I've heard about as well in the context of this. It's in the processing part only, and there it's used in those closed systems that I mentioned already before. And the way it is planned, and this makes economic sense as well, you try and use only as little as you actually need for the process. Yeah, so there shouldn't be any left over because that would actually be waste, and sulfuric acid costs money and you don't want to spend that money. But even then, so any air coming out of that process, for instance, because we're talking about air, it has to get into the air in order for sulfuric acid to rain down from that air. There is plans that any air coming out of that process go through air purifiers and through scrubbers as well. So again, multiple layers of protection when it comes to potentially sulfuric acid getting into the air. But for sulfuric, that's why I had to laugh, to rain down, that would actually have to be a lot of sulfuric acid, and that's next to impossible from that process.
This is why we have you here today, to explain from the very facts. Is it possible? Is it not possible? Because it's circulating in the media, especially when it comes to sulfuric acid. Someone tells you you're going to be killed by sulfuric acid. Yeah,
well, that potential is certainly there. But again, sulfuric acid is a chemical that is used widely in many of our industrial processes. So it's not specific to the lithium processing in the Jadar project. It's been used all over, has been used in mining, but it has been used in other industries as well, all over the world for many decades. So that is nothing new.
It's good that we explain that it's not something new. It's not something that's going to be experimentally used here.
Exactly.
Great. How achievable is the goal of fully replacing fossil fuels with renewable energy sources? So back to renewable energy, because this is all about new projects and renewable energy.
Yeah. I would argue we have to. Climate change is already happening. And if we want to avoid the catastrophic consequences of climate change, i.e. getting above, we are almost at the 1.5 degrees, which was sort of the lower of the Paris Agreement, which is this international contract the world has put in place to limit climate change or the temperature increase from climate change. We are almost at that 1.5% or degrees. If we want to keep climate change below 2 degrees, which is sort of the next upper threshold we gave ourselves as mankind in the Paris Agreement, then we have to get out of fossil fuels. Yeah? And in order to do that, the renewable energies will have to take over. And part of this renewable energy storage is actually lithium, because it will be used as for storage of electricity that is generated by those renewables. So we will need the lithium in our electric cars. We will need it probably for stationary storage of electricity. And current predictions say that we will need a lot more of that lithium in order to get away from the fossil fuels.
We've been talking about these new energy ideas and new raw materials that are not really familiar that much among the people that are not in this industry. So do the raw materials necessary for this process carry a new kind of risk, potentially making the transformation of the energy sector ineffective? What would you say?
From a climate change point of view, I would say, no, that is not the case. That's why we are actually doing this. From an impact on other environmental aspects, such as water, such as soil, etc., there might be additional risks. So if we mine metals, for argument's sake, then those metals can have an impact on soil as well. Yeah, but we keep forgetting that mining fossil fuels, coal, etc., oil and gas also has had an impact on those areas as well. So again, we need to avoid those risks materializing, but we've accepted those risks for many, many years, even centuries, with regards to the fossil fuels.
All this story here is about sustainable mining. But how is sustainable mining ensured, particularly when it comes to critical materials that are necessary for the transition to the green agenda we've been talking about?
Mm-hmm. So I think we, in this case, all of us need to ensure sustainable mining. In this case, it means...
Sorry, when you say we who are we?
The general public. Yeah, and that's in Serbia, in Europe, globally. I think we need to hold the companies who do the mining accountable for how they set up those projects as well, in order for them to use advanced processes that are responsible at the current stage, but also to keep going with further developing those processes towards being sustainable. And one example of what they mean with this is, I mentioned before, the tailings, and how Rio Tinto plans to store them in a process called so-called dry stacking. So dry them up rather than sort of wet tailings disposal, which needs much less land, which is safer from a stability point of view, which doesn't allow water sort of to penetrate those tailings, or much less so. That hasn't been... It still isn't actually state of the art. So now Rio Tinto wants to use that methodology going forward, and so it should be. Yeah, but that's not sort of the end of the road. So this is sort of where us, for instance, with our university, raw materials focused university, comes in with our research to make the next step then in this as well. And for arguments or a reason why I'm here today is I want to talk I am talking with Rio Tinto, can we actually use those tailings for construction purposes, for instance. So further research is needed to look into this, so that at one stage, 10, 15, 20 years from now, we might not need dry stacking of tailings at all anymore either.
It's important to say that stability is the crucial word here.
In the case of tailings, yes, absolutely. Particularly when it comes to wet tailings disposal, which was sort of, and to some extent still is, the predominant technology around the world being used. There's been some accidents. In Brazil, I think that made the newspapers some years ago, in Canada, etc. In Hungary, some 20 years ago, when those tailings dams that hold that material in place actually failed. Yeah? With dry stacking, this cannot happen. It's a different technology used for holding those tailings in place.
We have you here today as an expert to talk about your experience, your expertise, but we do know that every company needs to make some money. So when it comes to economic effects, such as profits for companies, profits for states, profits for different communities, so how is valued in new project? The value that the project is going to generate is important compared to the potential environmental impacts.
Mm-hmm. So, that is actually a big part of my research as well, that we try to look into sort of the environmental disbenefits caused by mining vis-a-vis the economic benefits caused. The reason why we mine actually is we need those materials. So lithium, in that case, we need for the batteries, I've already mentioned before, but whoever is involved in those processes wants to make a benefit, wants to make a profit from this. And the value for us is using those materials in the end. I mean, we have those batteries in our watches, in our phones, etc. And from this, we get value. Yeah. I don't think anybody wants to miss the mobile phone these days, which would not actually be possible without those batteries. So we're getting that value, those benefits from the mine, and that includes the profits from the companies involved. That's why they are doing this process. And on the other hand, we have those disbenefits, the environmental impact on land, on water, on the air. And we have to keep them as low as possible so that the benefits from mining those materials outweigh the disbenefits caused. And bringing that again back to lithium, in this case, the disbenefits caused by mining, processing, and establishing the batteries need to outweigh, for instance, in the case of CO2 emissions, that there will be CO2 emissions involved, getting to those batteries. Again, we have to reduce them probably to zero, or as close as possible to zero over the next years and decades, in order to be able to get, for instance, combustion engines, cars off the road, and with that reduce the emissions coming from those. So that in the end, we are creating environmental benefits by limiting over the whole value chain, as we call this, from sort of mines to the batteries that we use, the alternatives, in this case with the cars, the combustion engines.
Professor Tost, in your career, it's all about getting together mining and sustainability. Back in days, within the World Economic Forum, you actually initiated a project that was called Mining and Metals in a Sustainable World. So what insights have you gained from that project?
Yeah, that project, we actually tried to envision a world, and back then we looked at 2050. So we imagined a world that with all that transition that we've discussed today, the energy transition away from fossil fuels to the renewable energies, we imagined a world that has achieved that transition. And then we looked at, in such a world, we would still need the materials that are being mined. And how would the mining process then look like? Yeah, and for instance, then we talk to a lot of experts in that field. We talk to researchers, and for instance, some of those elements that came up was mining would have to be carbon neutral. Yeah, mining would have to be water neutral in a sense that the water would have to be recycled completely, and there would be no more water emissions coming from those sites. Mining would be underground because that way we minimize as much as possible and ideally close to zero the impact on the land. The waste from mining would actually be reused in other processes. So I mentioned before that is research on the agenda for the Jadar project at the moment. So many of those things that I've mentioned in our conversation just before, they were actually part of the work that we were doing there. They were part of that vision on how mining should and has to look like in a sustainable world. And now part of, again, our research at the university is really finding those solutions to make that vision a reality.
So, in your opinion, when it comes to critical raw material projects being developed, not only in Serbia but across Europe, do economic interests and geopolitical considerations or broader societal and environmental concerns prevail?
I think both play a role. So when you look at environmental constraints, climate change, as we've already discussed it, plays a very big part of the raw material needs. Let's stick to Europe as Europe sees them at the moment. So all those materials needed for the energy transition, Europe earlier this year came up with what they call the Critical Raw Materials Act. And through this Critical Raw Materials Act, one goal in that is, for instance, that those critical raw materials and many of those needed for the energy transition are considered critical. 10% of those materials should be mined within Europe. Yeah? And then there is additional targets for recycling those materials within Europe, processing within Europe, etc. But the point there is Europe sees a geopolitical dependency in those materials with other countries from outside the European Union, particularly China plays a very strong role here. So in order to get to those environmental goals of zero carbon emissions, for instance, in this case, the goals of the Green Deal, Europe has to do more mining, more processing, more recycling within its borders as well. So there is a very close link between what environmental concerns and sort of those geopolitical concerns with regards to raw materials.
And last but not least, to conclude our today's conversation regarding this issue, there are many activists who are concerned because aside from Serbia, it is sad that similar minings are not being open across Europe. So can you tell us what is the situation in your Austria, but also across Europe? Are there plans to open new mines? Is it safe to do so?
Yeah. So those plans exist in that context that I just mentioned, energy transition with regards to lithium and critical raw materials. So there is lithium projects, for instance, in my home country in Austria. There is lithium projects in Finland. There is lithium projects in Germany, in France, in Portugal. Yeah, and they are also similar to the project here in Serbia at various stages of development. Some are further advanced. To my knowledge, a project in Finland, they are planning to open and start mining end of 2025, 26, early 26. Some of them are 2, 3 years, 5 years away from starting to mine. Serbia is not alone with regards to this. It is happening in other countries as well. And again, if we want to achieve the goals of this energy transition, to move away from fossil fuels, in order to reduce catastrophic climate change, we will need those raw materials. And we will need raw materials, I guess in this case from Serbia, as well as from other countries within Europe as well, in order to achieve that geopolitical minimum 10% or more to come from within the European Union, to come from within Europe.
In the end, I like asking my guests after each show, what would be your message for the Serbian society?
I would say again what I said before, look up the facts. So underground mining is the case here. Open pit mining is not a fact. Sulfuric acid rains is not a fact. Look up really what the facts are. Compare them with what sustainable mining actually means, and we talked about that as well in terms of those visions, and then ultimately hold the company accountable for sticking to those plans and delivering the mine, the project, in accordance with sort of those plans, those visions for sustainable mining.
Thank you, Professor Tost, for this insightful conversation and for helping us to understand the facts.
Thanks for having me.
Bio je to profesor Mihael Tost sa Univerziteta u Leobenu u Austriji. Vi ste gledali još jednu emisiju Pola, sata, Demostata. Nadam se da smo ovim pomogli da shvatimo kako funkcionišu činjenice kada je u pitanju održivo rudarstvo i kada je u pitanju ono što je danas najaktuelnija tema u Srbiji, a to je otvaranje potencijalno i život projekta Jadar. Moje ime je Tamara Bajčić. Do sljedećeg viđenja. Prijetno.